Hey geometers, we were wrestling with this particular proportion at the end of class today, and I wanted to go through and show you why that ratio of 3 to 17 works in this particular triangle. In order to do that, I'm going to set up a couple of auxiliary lines. So I'm going to draw in a line parallel to KM. And then I'm going to extend LK. So I'm creating a triangle to work off of. Okay? And then that way we can go back to the earlier theorem about proportionality when we draw a parallel line to one of the sides of the triangle. At this point, we have some interesting things going on. Down here, let's call this LM. Let's call this corner P. Down here at corner P, we actually have a corresponding angle with angle LKM right up here. So we know that this angle is congruent to angle LKM. And then over here at angle KNP, we also have an angle that is congruent to MKN by alternate interior. So those auxiliary lines that I drew in actually now produce an isosceles triangle where this segment, KN, is congruent to segment KP. So we know that KP is 17 units long also. So now we can go back, let's label that segment that we're looking for as X and LM as 15 minus X. So now we can set up that proportion of 3 over 17. And we can set that equal to 15 minus x compared to x. Okay, so when we cross multiply, we're winding up with our 3x. And then we have 17 times 15, which is 225, and then minus 17x. So now at this point you can go through and solve for x, and that will give you the length of segment MN for this particular problem.